Hi folks, this is Marco Saze here with Team XL Power, Eagle Drift, and Data Servos. Last Fun Fly at Snohomish, was talking to Nick Maxwell, and he explained the importance of static tracking. And I wanted to show you sort of like a simple way to check it, that if you don't have a micrometer style dial indicator, or if you don't want to carry one when you go to fun flies. So what I that so what does it mean to be statically tracking correctly? It basically means that you need to have the shaft axis here orthogonal to the shaft, the feathering shaft.
Okay, so here's a quick diagram showing why static tracking is important to avoid the head wobble as the blade spins. Well, as the vertical line represents the shaft, the main shaft, and the approximately horizontal, to not 100%, 90 degrees with the main shaft, represents the feathering shaft. The two arrows represent the centripetal forces on the blades on one side and the other side, or basically everything that is rotating. And they are orthogonal to the main shaft because, after all, they're spinning around the main shaft. The problem here is that when the feathering shaft is not 90 degrees with the main shaft, as the blade spins, the blade that is coming out of the page, let's say the blade on the right is coming out of the page, the centripetal force is not parallel to the shaft. The centripetal force has a slight upward component relative to the feathering shaft, so that's pulling the feathering shaft up. And conversely, the blade on the left, as it's spinning, let's say it's going into the page, the the force component, there's a force component that is orthogonal to the feathering shaft that has a negative projection, so a projection going down onto the feathering shaft. So what that does is that it causes a droplet, that there's a moment, a torque applied about the center, the center point there, and that torque is going to follow the blade as it spins, meaning that it's going to go from rolling the helicopter, then pitching, then rolling again, and then pitching, and this is going to cause a head wobble, as the blade slows down. And obviously, when it stops, then it doesn't have those moments anymore.
If you assemble your heli, you notice that when these screws are loose, because of the machining, you need the hole for the main shaft to be slightly bigger than the shaft itself. So otherwise, you wouldn't be able to mount it here. It would be too hard. You have to put it in a press. So so if you notice, when you're assembling, there is a little bit of a play here before you tighten. So that means that if you tighten in one orientation, the angle is going to be slightly crooked in one way or the other way. So what you want to make sure is that as you tighten it, this angle is orthogonal to this angle here. Okay. So luckily, the XL Power helis and some other helis from other brands too are very helpful, and they provide you a flat spot here. And it turns out that in the machining process, this is machined all in one step, in one installation of the main piece of aluminum, which means that the CNC comes and makes this hole and planes this part, so that means that it's as precise as the machine. So this plane should be parallel to the axis of the feathering shaft. So what I do is I get one of these levelers that have two lasers, and I install it here, like on the flat spot. In the case of this particular one, the V1, it everything is flat across the board, so I can put it without a spacer. Here I put a spacer that is parallel, and I want to install this, and I shoot two lasers. And when I spin around, if this is orthogonal, the trace of one side on a wall of that laser and the trace of the other side should coincide. If they are not, if it's not orthogonal, one trace is going to be higher than the other one. So I'm going to pause the video here. I'm going to install, and then I'll show you how it looks like. All right, so this is how I installed the level. As you can see, it's touching on the flat spot of the head. And it has a laser shooting out on this side and a laser shooting out on that side. So this is still loose. So I'm gonna carefully spin here, and I put a reference there as on the wall, so you can see that the laser is, this side is slightly lower than the line. And that is slightly higher than the line. So what you then do is you slowly tighten these screws, starting from this one, from the main one. And as you're doing, make sure that you're trying to push either in the direction that is high, push down in the direction that is high, so that you're slowly tightening and making sure that you're getting those two lines there as you spin very close to each other. So here is still as it was. Okay, so that's the principle. It's pretty simple. I'm gonna now do the process, and then I'll show you after I'm done how close I can get with this. Okay. All right, so I did the process, and now it should be as close to level as possible. As you can see, it's slightly off from the reference that I started with. So now let's observe the line. So first one is just above, just touching the top edge of the tape. Let's see the other one. Yeah, that looks pretty damn close. So there you go. This is a pretty easy process. It should help you out if you're like on the go and you don't want to carry a micrometer, as I still think that the micrometer is the ideal way to do it. But if you don't have that, you can just carry one of these and use it as a pitch gauge as well. Okay.